Have you ever looked up at the sky and wondered, why is the sky blue? Or maybe you've watched a breathtaking sunset and thought, why does the sun turn red as it sets? It might seem like magic, but it's all science. And it starts with something called Rayleigh scattering. Stick around because by the end of this video, you'll be able to explain this beautiful mystery to anyone and sound like a genius doing it. Let's start with light. What we usually call white light from the sun is actually a mix of all colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Each of these colors has a different wavelength. Red light has a longer wavelength. Blue and violet light have shorter wavelengths. Now imagine light traveling through the Earth's atmosphere, which is filled with tiny particles, mostly nitrogen and oxygen molecules. Here's where the magic happens, something called Rayleigh scattering. This is the scattering of light by particles much smaller than the wavelength of light. In our atmosphere, these particles are gas molecules. Rayleigh scattering affects shorter wavelengths more strongly. That means blue and violet light are scattered in all directions, much more than red or yellow light. You might be wondering, if violet scatters more than blue, shouldn't the sky look purple? Great question. The answer is twofold. Our eyes are more sensitive to blue than violet, and some of the violet light is absorbed by the upper atmosphere, so what we see is a sky filled with scattered blue light, hence the blue sky. Okay, so that explains why the sky is blue during the day. But what about those stunning red, orange, and pink sunsets? As the sun gets lower in the sky, the light has to travel through more of the Earth's atmosphere to reach your eyes. That means more air molecules, more dust, and more particles to scatter the light. Now remember, shorter wavelengths scatter more. So by the time sunlight reaches you during a sunset, most of the blue and violet light has already been scattered out of your line of sight. What's left? Mostly the longer wavelengths, red, orange, and yellow light. That's why the sun and the sky around it look warmer in color when it's near the horizon. It's like the atmosphere has a built-in color filter. Add in a bit of pollution, dust, or clouds, and you can get even more dramatic, fiery sunsets. Because those particles scatter light in complex ways that enhance the red and orange tones. Let's compare. At midday, the sun is overhead. Light travels the shortest path through the atmosphere. Less scattering equals the sky looks bright blue. At sunset or sunrise, the sun is near the horizon. Light travels a longer path, meaning more scattering, especially of blue light. What's left? Warm reds and oranges. And during golden hour, the balance of scattered light gives everything a soft, glowing quality, perfect for photography. You might ask, if scattering fills the sky with light, why is it dark at night? Simple, the sun isn't there to illuminate the atmosphere from your perspective. No sunlight, no light to scatter. So the sky turns dark, letting us see the stars, planets, and the moonlight, which is actually just reflected sunlight. Let's wrap it all up. The sky looks blue because of Rayleigh scattering. Short blue wavelengths are scattered in all directions. Sunsets are red because the light travels through more atmosphere, scattering away the blues and leaving behind reds and oranges. It's all about light, wavelengths, and how our atmosphere plays with them. Nature's way of painting the sky with science. Pretty amazing, right? If you learned something new today, hit that like button and don't forget to subscribe for more cool science explained simply.